Hello CIS18A, this is part 2 of Unit 3 lecture, which covers chapter 5. In this chapter we're mainly going to talk about array. So just like C++, Java has array, which is a container where it would store the same type of a collection of items. It could be numbers, it could be prices, it could be strings. So arrays can have multiple dimension, but to start we will touch on the one dimension array and then we will move to multidimensional array. So this is a way that we would group related items or elements together. So to start, what we want is we want to be able to declare our array. Just like a variable, we need to have a type. So if you have an array that store integers, you would have int here. If you have an array that store prices, you might want to try double there. So then you would give it a name, just like how you would name a variable. It has to be unique. It cannot be keywords. It cannot be reserved words. So you can declare an array, and how can we tell if it's an array or a variable? Is that when we use the square brace. So the square bracket here indicates that it is an array. Now that is if it's a one-dimension array. If you have two-dimension array, you would use two square brackets. And when we declared the array, we wanted to tell the system what is its size. How many elements is it going to contain? If you have an array that holds 10 numbers, you wanted to indicate the 10 there. So now array in Java, important to note, that is dynamically allocated using the new operator. So the way that we can declare an array like this is that we can say int sample, this is our array name. We use the new operator and would say int 10. This array holds 10 elements, and the 10 element is then linked to that array. We can do it another way where we would say int sample as we declare the array, and sample is new int 10. So now in an array, what we have is we would have an index that would represent the position of each of the elements, starting with 0. So 0 indicates the first position for the first element. So the first element is indexed at 0. The second element is indexed at 1, and so forth. So when we have 10 elements, we would start with index 0 and we would finish at the last element at index 9. So index really describes the location or the position of the element inside that array. So let's take a look at this program. We have a class called ArrayDemo, and we have a main method. Inside the main method, we declared an array called sample, and we're using a new operator to dynamically allocate space for this array. This array holds 10 elements. Then we have a for loop, and to iterate through that array, meaning that we're going to access each of the element of that array. We're going to start with the first element, which is at 0, and we're going to go up to 9, which is the last element in that array. Then for that we're going to access each of the element value as we would use the index here and the array name. Then the second for loop, what we would have is we would again use the index to access each of the element of the array, and we would print this out. This is sample, and we would say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the output for that is what you see below here on page 20. And array is easily implemented to store a group of values, right? Like, or a group of objects, items. So you might have an array that would store names of all your customers. You might have an array that would store prices for all your products. You might have multidimensional array that would have product name, product description is the second dimension, and the third dimension would be product prices. So in an array, to illustrate it in a 2D level, you have the first element resides at index 0, second element resides at index 1, and so forth. So in the 10 element array, we would start at index 0 and we would go to index 9. So now if we want to access the fourth item, we would use index 3. So to initialize the value for the array, we first would have the type of the array, the name of the array, the square bracket. Then we would use the equal sign to say that now we're going to assign the value, and we would then open the curly brace and we would have the value for each of the element all the way to the end, and then we would close the curly brace and finish out with a semicolon. So an example of this is on page 21. We have an array called nums. It's holding integers. And to initialize the value, we have the curly brace. So 99 is the value for the first element. -10 is the value for the second element. And the first element is at index 0. The second element is at index 1. And so when we initialize the values for the array, we would have them enclosed in the curly brace, and we simply use the equal sign like how we would initialize value for a container like variable. But unlike the variable, we would have the curly brace to indicate that it's a group of values for the group of items, which is an array. And you often see the for loop being used to be able to access each of the element in the array. So here what we're saying is that we're trying to determine the min and the max of nums. So in the for loop, we would start with 1 and we're going to go up to 9. And so if the value in num is less than min, then it's going to show that. So now the value of in num is greater than max. It's going to indicate the value. It's going to store the value in the max. And we're going to display that min and max. So what it's going to do is going to check every single value in this array, and it's going to determine which value is the lowest and which value is the highest. Now, it tells you here that array boundaries are strictly enforced in Java, and so it is a runtime error to overrun and underrun the n of that array. So you can look through the example and you can see how it would iterate through each of the element from the beginning to the end of that array. Next, we're going to talk about multidimensional array. So earlier I mentioned that you might have two-dimensional array to store your product name and your price. So basically, it's a group of items that's nested in another group of items. So in the two-dimensional array, we would see it like this. So we have an array named table. It is a two-dimensional array. We can tell that it's two-dimension by 2 of the square brace. And the first dimension has 10 elements. The second dimension has 20 elements. And the way that we should think of this is it's going to be like a table with an X and a Y, rows and columns. So it would have 10 rows and 20 columns. So each of the dimension is indicated with its own set of brackets. And the value that goes in here would indicate the number of elements for each of the dimensions. So this one has 3 elements in the first dimension. The second dimension, it has 4 elements. And when we want to iterate through that array to access each of the element value, because it's two-dimension, we would use a nested for loop. And in this case, the first dimension has 3 elements. So we're going to go from 0 up to 2. And we're going to count up. For the second dimension, we're going to go from 0 up to 3. And we're going to iterate up. So now to access it, we would have it with the t and the I variable here as its two-dimension. And so we would operate that we would take t times 4 plus I plus 1 is the computation process, as it would loop through for both dimensions. So the way that we would look at this is, so in this example, when we're at 0, 0, we're accessing 1 here. Okay? When we're at 0, 1, we're at 2. 0, 2, we're at 3. So think of the left index is going to be the row, and the second index is going to be the column, which is the second dimension. So when we're looking at table 0, 3, 0 is the row, 3 is the column, we're accessing 4. 0, 2 is the 3. Now if we're doing 2, 3, so 2 is the row and 3 is the column, we're accessing 12. So this is how you can utilize the index for multi-dimension. In our example, it's two-dimensional array. On the next part, it talks about irregular arrays for multidimensional array. So then you would need to specify only the memory of the first leftmost dimension. You can allocate the remaining dimensions separately. So in the example here, we only need to indicate the 3, which is the allocation of memory for the 3 elements in the first dimension. And then we can refer to 0, 1, 2. Those would be allocated for 4. So you do not need to indicate the second if it's the same index. So it says here on 22 and 23, just to repeat that. For example, when you allocate dimensions separately, you do not need to allocate the same number of elements for each index. since multidimensional array are implemented as arrays of arrays, the length of each array is under your control. So we only have to indicate one allocation as it is group nested within groups. So in Java, you can have more than 2 dimensions. You can have 3 dimensions or higher. So in the case where we have 3 dimension, we would use the 3 set of square brace, and then we would specify certain size here for each of our dimension. So in the example, if we have a 4 by 10 by 3, we would have the array name showing 3 dimension, and it would have 4 by 10 by 3. So to initialize multidimensional array, we would initialize them using their own separate set of curly brace. So in this format, when you have 2-dimensional array, you would initialize them with 2 separate curly braces there. So with the provided example, you can see here that we have an array called SQRS for squares. It's 2 dimension. Now you would have each row has its own set of initializer. 1 and 1, 2, 4, 3, 9, and so forth. So what you would have is you would have each set contained in the curly brace. And then since it's 2-dimensional, we would have a nested for loop. So to be able to access the value to illustrate the square. So square 1 of 1, 2 is 4, 3 is 9, and so forth. So again, in this one, since we're using 2 dimension, we would initialize them with their own separate grouping for X and Y. Okay, then next we're going to talk about how we can declare them alternatively. Here we have an array called counter. It has 3 elements. We can use int, the square brace, and then counter, and that will be an alternative way to declare it. We can do char table. This is for character, 2-dimensional array. We can do it 3, 4 traditionally, or we can do char with the square brace. So the type with the square brace automatically indicate that it's also an array and the name following. And then here we can give it the size. So this allows us to declare it differently with the type following by the square brace, or the type, the name, and the square brace. So there are alternative ways to declare arrays in Java. Now on the next part, we're going to talk about referencing variable, assigning one array reference variable to another. You can simply change the object, what that variable refers to. So in this example, you have one array called nums1, another array called nums2. They contain 10 elements in each. You use a for loop to access nums1, another for loop to access nums2. Then we would have the output, also a for loop to print each of the element. Then on this line, we would reference nums2 to nums1. So nums2 is going to refer to nums1. And then we would use a for loop to access nums2 to show the value from that array. And if we wanted to access the fourth, to operate the nums array through nums2. If we want to access a value from a certain index, we can put that index value in here. So if for the fourth element of nums2, it's going to be the same as nums1 as they contain the same number of elements, which is 99. So if you're accessing only one element, you can simply use the index value like this. But if you wanted to access all the elements in the array, you can implement the for loop, start it at 0, go up to the number of elements that it contains, and then we would be able to display each of the value. So in the example, it shows that we can use nums2 to access num1s as we would reference it with the assignment. So each of the array would have the length instance, or the length would refer to the size of the array, the number of elements that it holds. So when you initialize an array in this example, int nums have initialized elements 1, 2, and 3. So automatically we would have a length of 3 elements, where in the previous line, int list doesn't have any initialization yet, but it contains 10 elements, so its length is 10. So now for the variable length table, with the table, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, we would have a variable length table where it would be 2-dimensional for that table array. Now, we can also use the dot length to control the for loop. All that means is it's going to plug in the number of variables, the number of items, the number of elements in that array for length here. So you can use it like this, or you can simply use the numerical value as the number of elements for that array. So we can use the length member to control our loops, and that is just going to indicate the number of elements. Okay. So here are some examples of the expressions. We can use table.length. This is used to obtain the arrays that's stored in the table, which is 3 in the case. Or we can use to obtain the length of the individual array in the table. Because it's multidimensional, we can use it to indicate for the expression with the individual array using the value. Here, the length member is used to compare the array size. So we have them both at 10. nums1 has 10 elements, num2 has 10 elements. And we can say if nums2.length is greater and equal to nums1.length, then we would have a for loop to access nums1 from 0 to the end of nums1, and then nums2 in value is going to be assigned to nums1 value element. So now what you can have is you can have the dot length to be used to control your for loop, or we can use it to compare the length from each of the array, nums1 and nums2. so we can compare the array sizes using dot length. And in the next part, we're going to talk about for each loop cycle with the collection object. So in this one, for the statement, you need to include the type. So for each style, we first have the for, and then we would have a variable, and with the next, as the format indicates here, the iterator variable, and then the collection. After that, we would follow it with the statement block. So in the example that's shown, basically with each of the iteration of the loop, the next element in the collection is retrieved and stored into the iterative variable, and the loop repeats until all the elements of the collection have been attained. So for each style, we would have a for, a variable, and a collection. And the collection is coming from int nums, which is an array. So it's going to take each of the value it's going to store into int x as it iterates through. So first it's going to take 1, put it in here, and then next it's going to take 2, put it in there, and it would add it. Our statement is to add 1 with 2, with 3, with 4, with 5, with 6, all the way up to 10. And this is a different way that we can use a for loop. And this is the style called for each style, which automates the preceding loop. So you can use a traditional for loop, or you can use it for the for each style for loop to be able to access the element values inside an array. And so as you can see, it accesses each of the value, and then when it sums, it totals all of them up. And I recommend testing out the for each style loop, so that way you can have experience with writing your for loop a different way, as you would often see for loop is being used in iterating a container like array. So the example you can see on page 32, 31, and 32. In the next part, let's talk about string. So since the first week, we started using string in our system out print line. We had printed out text, and we enclosed the strings using the double quotation mark. So in Java, strings are objects, and string can be constructed just like how you construct any other type of object, as what we've seen previously in the other examples, using the new operator and calling the string constructor. So here in this example, we have string, and the object is called str. We're using a new operator here, and we would call on the constructor string, and we would have an argument hello. So what this does is it creates an object called str, which contains the string hello. So at this point, you construct a string object that has hello. So now another example in the next page shows you how you can construct a string object from another string. So what we have is str is the object, and it contains hello. And then we have str2, which is an object that contains str, which ultimately contains hello. So str would then contain hello, as it is containing the first object. So on 34, also show you a complete program on how you can use string. And in your lab, I refer to this example, and you are to create different objects to have updated with your school information, your program, what discipline you're studying under. So in this program, you have a class called string demo. Inside that class, you have a main method, and then you would declare the string object. So the first string object, str1, contains Java strings are objects. The second, str2, contains, this one is a primitive assignment. They are constructed various ways as strings. And then string 3, str3 object, is the same as str2. So when it prints, it would print Java string or objects as what you see here, as str1 holds that string. And the next two print, because str2 and str3 is the same, it would print they are constructed various ways twice. So another longer example, you can find that on the next page, where it would have the complete program using different objects, how to be able to print out different string and update the string object using another string. And also illustrating how to use the equal method, which compares the character sequence into two strings. So we can use the double equal sign to compare the two string, or we can use the equal method for comparison of the two string in Java. And in the text and the notes provide you example of the array of strings. So when you use the array of string, you can use the array of string for your course project in such that you would list different product name or description or services description. So the example gives you a program that actually contain an array of strings. This is a test, and you would then use the for style loop to be able to access each of the string inside that array after it was initialized. So some of the important things to note, and this section talks about strings are immutable. So the content of string objects are immutable. Once it's created, you cannot change it. You cannot alter the character sequence in that string. So in the case where if the string already exists, you can simply create a new string that contains whatever changes that you need to make. In Java, there's a class called string buffer, which creates string objects that can be changed. So in the case, if you need it to change, you can use string buffer. However, for most purposes, when you use string are immutable, as in the sequence of that string object doesn't change. Now, if you wanted to cut the string into smaller substrings, you can use substring method, which return a new string that contain a certain section of that string once it's invoked. And the example on page 37 shows you how you can use substring to slice down the string to smaller portions using substring method. And the parameter or the arguments that you use here basically that contain the positions of how you wanted to slice down that string to a smaller substring. So the output of this, as we position that, the original string is Java makes the web move, and we wanted to cut Java out, so we simply, and move out, so we simply use the argument to place the position where that substring would be, 5 and 18. Start and finish for that slice. Next, let's talk about switch. And last week we touched on switch, using switch to provide options, but for using string in the switch control statement, because in the last week we talked about using integer type like 1, 2, 3, 4, 5 for each of the option. This week we're going to talk about how we can use string as your switch option. So instead of using if-else ladder, we can use switch statement to control how your program would flow. So in this example, we have a class called string switch. Within it, we have a main method, and we have a string command, and it's defined as cancel. Now, if we're using a string in the switch, we first would have to declare this command here, and command is then going to be used as parameter for the switch. So now in the case where we use connect, so the first case is going to be connect. So instead of using an integer like last week, we now use a string. Case connect. We then would print connecting. Case cancel. We would print canceling. Case disconnect. We would print disconnect. So yes, you can implement string for the switch case instead of using numerical value or integers like what we seen last week. So when we output this program, if we select cancel, then it's going to output canceling. And this is an example to illustrate how you can use string for your switch statement. With the next part, it talks about how you would use command line arguments. And Java, here the example shows you on how you would use CL demo class, and you would be able to use the command line arguments for your Java program. And for the first argument that's shown, that's 1, second argument is 2, and the third argument is 3. So we simply storing the index. So with the arguments, it's going to take one command line argument, and it's going to point to the specified, the initialized name that's in that array. So in the string numbers hold two-dimensional array. In that Tom and their phone number, Mary and their phone number. So what that will do is going to search through the two-dimensional array, and it's going to find a match for that particular individual based on the argument that's provided, that was input. So using the argument, the program after it's ran, it's going to give you Mary and her phone number based on the argument that was given. Next, we're going to talk about local variable, and the type inference. So there are two aspects in the variable. First, the variable must be declared prior to use. We covered that in the first week. Second, the variable can be initialized with the value after it's declared or when it's declared. So to streamline, first, for most part, we started using the local variable, which would be contained in its class. Now, the local variable type inference would be that it would involve with the context of the identifier var, then it will be added. So in the local variable inference, the variable must be declared as var as the same type name, and it must be included in the initializer. So the first example here, we have double AVG, and we initialize it at 10.0. To do the type inference, we would do var AVG is 10.0. So AVG originally was typed as double in the first case, but in the second case, AVG now then is inferred as a double because its initializer is 10.0. And we use var. So var added the context sensitive identifier for that variable and it's used as a type name to the context of after that as we declare that variable locally. So the compiler would then use the type inference to determine the type of that variable being declared as the base type in the initializer. Var is just a placeholder for the actual inferred type. So I highlighted the section that you need to look over as you look at the example for the type inference with the local variable. We talked about how we would use var to infer the type for AVG as it is 10.0. So if you're not sure if you don't want to use a specific type, you can also use var and also the same for the array. So in this example, we use var my array, and we have 10 elements for that array. Notice that the var no array has any brackets because it's inferred as int with the square bracket. So this is going to be valid to use if we wanted to infer for the array. Okay. Now, one of the things that you need to remember is that var can only be used to declare local variables. It cannot be used to declare instance variable, parameters, or return types. So the example that it shows you here for the local type inference with the referred types, with the my_str is the string, and this is the string, and then var my sub_str is my str dot substring, and to cut that string. So str is inferred to be string, and my sub_str is inferred to be a string because the reference is returned by the my substring method in the string. And then make sure that we understand how to use inference of local variables and array. So for our next part, we need to touch on bitwise operator. And bitwise operator can be used with different types like long int, short char, or byte. It cannot be used for Boolean, float, double, and class types, and that's important to remember. So bitwise operator can be used for long, int, short, char, or byte. It cannot be used for Boolean, float, double, or class types. So what are the operators? You can use ampersand for and. We touch a little bit on this in week 1. We can use the pipe for bitwise OR. We can use the hat for exclusive OR. We can use the double arrow to the right for shift right, triple arrow to the right for the unsigned shift right, double arrow to the left for the shift left, and the till for the complementary and unary not. And with the bitwise, we touch on how we would use it with the operator bitwise and, or, XOR, not, and so forth. So to do a bitwise program, your textbook and your note shows you how you can use the bitwise to be able to output the uppercase letters given the lowercase. And also the lowercase letter is to follow in that program. Now, for exclusive OR operator, exclusive OR is used with a certain value to result XOR for that letter, that value. So we can use exclusive OR to be able to produce a certain character instead of using the ORing of a value for that character. So this program illustrates a little bit more on how you would use bitwise operator to be able to output certain characters given an initial character to start. Now next we're going to talk about the ternary operator, which is seen as a question mark because it's using 3 operands. It can be used in place of the if-else statement. So in the if-else condition, it checks when the condition is true, then it would execute the expressions. Otherwise, it would go to the second expression there. So with the ternary operator, it requires 3 operands. It takes the first expression, the second expression, and the third expressions, where there would be a Boolean expression for the first, and the second and the third expressions are either type or void. And the second and the third expression must be the same or compatible. So in the case where if we wanted to replace the if-else statement, we can use ternary operator. So apps val is val less than 0, and we would apply the ternary here, negative val to val. So get the absolute value of val. Now, if we write it with the if-else statement, if val is less than 0, absolute value is negative val. Else, absolute value is val. So the way that we can shorten it by using the ternary operator is that we can condense it to a 1 line to be able to avoid having to use if-else statement. So that gives you an example of how you would use ternary operator. There's also an example program to be able to apply that. Now, in the case where if you have expressions that are all type are Boolean, the ternary can be used as a conditional expression in a loop or an if statement. So you can implement it as a loop or an if statement. So here what you can see is you can see it with the if. There in the case we're using true false. So that's another example you can use to reference the ternary operator. And this concludes my video for chapter 5. Please look over the chapter in the text. Also examine the example, work on your lab so you can further understand how to apply the concept. And important to look over the materials, the notes and the text, and also the video. If you didn't watch part 1, please watch part 1 for Unit 3. And this concludes the 2 parts of my lecture video for CIS18A Week 3.